So hello everyone. Next question of stack playlist is LRU Cache, and in this we have to return the least recently used elements according to the operations. If we want, we can do three operations like put, get, and two operations like put and get. So initially, let's say in the cache element we are going to put 1 and 10. Then we are going to be put 3 and 15. These are in the key value pairs, so that means the key is 1 and value is 10. So, and also there should be like capacity given, like how much the cache size. So the initially, let's say in this case, size will be 3, so maximum elements can be pushed is equal to 3. So next we have 2 and 3. So now we have like capacity equal to 3 full. So now we want to get the key 3. If it is exist, then we have to return the value. So now it exists, and so LRU cache is like least recently used will be at the first position. So least recently used is now 3 because we are getting this one. So this will move here after this, and this will go here, and 12. So after that we want to push the 4, but capacity is now 3, so we can't put that element. So we have to remove some of the element. So the least recently used in between those three is the last element we have. So we can remove this element, and we can put our 4 and 25 value here. So this is the question here. So we have to implement this LRU cache. So let's see how we can implement that. Like I am thinking of we have to like link list between them, something like that, because we have to traverse again and again like that, and sometime we have to come back, because we want the least recently used, so it may be doubly linked list, I think so. So, and also we need two data structures here, like doubly linked list and hash map, I think, to track the key and nodes. Hash map. So how we can do that? Initially we can like initially we can do like we have head and a tail, like that. So and this is pointing to null, and this is also pointing to null. So and this is pointing to the tail, and tail previous is pointing to the head. So the initial scenario is this, and they are containing -1 key value pairs. So now we want to put 1 key and 10 value. So initially the capacity is 0, so we can put here because the capacity is less than 3. So we can put like here before a head, and head next will be point here, and the new node, let's say its address is x, uh, yeah, we can say x, and we will point the next to the tail, and the tail's previous will be to the new node, and the values in it are 10, 1 and 10. So now also we have to track into the map, like we are pushing key and nodes into the map. So we have to push like key is 1 and a node will be x. So this is basically the address of this node. Okay, so now uh, we have 3 and 15 to push into the cache. So also we have to increment that by 1 because we already have pushed the element. So head is pointing here and like this. So now the 3 and 15 will be after the head because the least recently used is move ahead by one place because the recently used will be the 3 comma 15. So that's how we can do 110 and then this is tail -1 with -1 and pointing to null. And now this is the x address, let's say this is the r address, and capacity will be increased by 1, that is 2 now, and this is pushed into the map also. So just like that we have to do the same operation with that. So how it going to be look, let's see. I make this quickly. 2 12 and head will be here with -1 and pointing to the null, and let's say address will be z. So 2 comma z will be pushed into the map also. So now we want to get 3. So first we will check into the map if any 3 will exist into the map or not. So now we find that key 3 is exist in the map, so we will get the address from here and we will go here, and then we have to to get this element we can directly get the value from the address, like we get the node and then we can return the address, means value of at that node. But one thing we also have to do, like we have to remove this element in this node from here and put this here because this is the recently used node. So after the get operation the doubly linked list will look like 315 and the address of this node get changed. So let's say it will be n now, and then all other are same now. So first we have to remove this, then we can add like what tail over. So what operation we have to do first, while getting the get operation, find if element or key is in map or not. Then if exist, then we can do like remove the node, and then again we have to add that node. So these function we have to write along with that, and we can return the value of that node. And if that doesn't exist, then we can return -1. So this is the get, and put will be like if we want to put, first we will check the capacity. If capacity is equal to value via means size, let's say size, then we can first we have to remove the tail previous node, and then and if the and also remove from the map then we will add add the node new node and also key node into map. So that's how we can do the put operation. And if the capacity is less than size, so we can directly add, means head next will point to the new node directly, we can say. And here we have to return, here we also have to return from here. So that's how put will look like. And two operations we are also doing, like removing and adding. So those functions we also have to return. So let's see how we can do them. So let's say there are this type of scenario exists. So to remove this any of the element, let's say we want to remove this, so we can we want to delete this element, and we can take temp previous will be the previous node and temp next will be the next node. So what we will do, like previous next will point to the next, and next previous will point to the previous. So that's how we can. And we can also remove these links by temp previous pointing to null, temp next pointing to null. So that's how we can delete this node. And if we want to add a new node, so every time when we add a new node, we want to add in front of head, because that node will be the recently used. So we want to add a new node here. So what we can do, like temp first we will point to that, let's say head next will be the pointer, and head next will now point to the new node, and point new nodes next will point to the pointer, and new nodes previous will point to the head, and new node like pointers previous will point to the new node. So that's how we can add the new element, new node, add node. So these are the function we have to return. So let's see the code, how we can code this up. So first we will have to define the what node will contain, what a single node will contain. So key value, next and previous for the doubly linked list. And if we are defining a new node, then we will do a constructor with key and assign that key to this key and this value to this value. Okay, then we will form two nodes which are initialized with -1 key values, head and tail, and capacity, so that we can access this capacity inside all of our functions. So that's how we can, that's why we are defining this globally in our class. So we will initialize with capacity, and next will be head next will point to the tail, and tail previous will point to the head. So the scenario now here is, so this will pointing to itself. I think you understand what I am trying to say. So for the getting the particular key value, first we have to find if that value is exist into our map or not. If exist, then we have to do these operation, otherwise we have to return -1. Then to do these operation, what we have to do, like node, first we will fetch the node from the map through key, that key we have to find, and then fetch the value to so that we can return after that. And then we have to erase this, like I have told you. To get this, you have to remove this also from the map, and then we can remove that node, and again we have to add that node so that it will be least recently used. And then we can again, after erasing, we can again uh, add a new key or node into the map, and address will be head next, because the head next will contains the least recently used. So for the put function, we first we have to find if the key is present in the map or not. If it present, we have to erase that from the map and remove the node. If the and also if the capacity of map is equal to the original capacity we have, then we have to erase that. That means the last element tails previous key erase from the map, and tails previous node we have to remove. This function we already written here, that I explained you. And after that we can add a new element with a key and a value that we have to put, and also put into the map. So these are like, so also we can refer to these like temp next, means temp will be the ptr I told you. This is temp there to add the element, and new nodes next will be temp, and temp previous will be the new node. So uh, these links are made by these two lines, and head next will be new node, and new nodes previous will be the head. So these two links are by those two lines. So next we have to remove. So we can consider the particular element, and means the previous and next element, and we can point it like temps previous will be the pointing to the temp 1, and temp next will be the temp only. So that's how we can do the least recently used cache.